And then for lithium nitride, again, breaking down the name, right, we have this "-ide" ending, which is your clue that it's binary, right? And then we would go look at a periodic table and find lithium. And we would see that lithium is right here. Lithium is in group 1, so this is definitely a type 1, which means that we are just going to do the charges, right? There's nothing extra that needs to happen. There's nothing extra anyway, I guess, doing in the formulas, because the formulas are delightfully straightforward for whatever type, where this is going to be 1 plus, and this is going to be nitride, which means it comes from, correct, nitrogen, right? Not to be confused with nitrate or nitrite, yes, right? Nitrate would be NO3 minus, nitrite would be NO2 minus. Nitride, though, is the nitrogen as an ion, yes? So this would be the 8, right? This would be ite, and this is ide, yeah? So making sure we pay attention to what the endings mean, right? So let's go find nitrogen on the periodic table and make sure we know its charge. Nitrogen is here, part of the -3s. So this is that, this is that. So if I have 1 is equal to 3, then I clearly need 3 of these and only 1 of those. So Li3N would be the formula for lithium nitride. Yes? All right, let's go in the other direction. Now what we've done is we've done the formulas, right? Where we need to identify that it's ionic. And once we've identified that it's ionic, we know that we have to make the magnitude of the positive charge equal the magnitude of the negative charge. Now for naming, right? Really all we're gonna do is employ this table, right? We're gonna figure out what its type is and then apply the rule, yes? You'll note, right, so assuming that you've done the whole chapter, I don't know, right, you'll see that what is not included in our in our ionic compound naming system, right, no prefixes, right, no numerical prefixes, right. Now, obviously, there are some weird polyatomic ions, right, like dichromate has a di in front of it, right, but that's part of its name, right? But note that there are no numerical prefixes, which differentiates it from molecular compound formulas, right, and naming. So that's one of those clues to look out for. Because everything is balanced by charge, there is no need for prefixes. Yes, does that make sense? So do be mindful about that every time you're doing an ionic compound, right? There should not be a numerical prefix. All right, so let's go ahead and do some practice. So we have Fe2O3, so we need to go find iron and oxygen on the periodic table, right? Here is iron, here is oxygen. So we definitely have ionic. Because iron is located here, it's going to be a type 2. And it's going to be binary because it's only made of 2 elements. So this is a type 2 binary. So we're going to follow the naming system, which says I'm going to use full name of the metal, charge, and then root-ide. Full name of the metal, which is iron, charge, and then root, which is ox, ends with ide. Okay, now I just need to figure out the charge of that metal. And here, oh my gosh, all we're doing is working backwards from the same thing we've done before, right? So I know, let's do this working backwards in a different color, right? So I know that I have 3 oxygens and I have 2 irons, right? So I already know this part on the line, yes? And I know oxygen has a charge of 2 because I know that from the periodic table. So I just need to figure out what this charge is. Yes, this is like our X. So what must X be? Correct. X must clearly be 3, right? X equals 3. So that means this is iron 3 oxide. Yes, does that make sense? And then we could actually work in the other direction and make sure that formula makes sense, right? If iron has a charge of 3 and oxygen has a charge of 2, how many of each would I need? And you'd see that that breaks down to 2 and 3. Yes? All right. Now let's do the next one. Na2O, right? So we have sodium and we have oxygen. We would go check our periodic table. Here is sodium, here is oxygen, right? Binary. So 1, it's an ionic. Type 1, binary, right? Ionic, type 1, binary, full name, root-ide. Full name, sodium, root, ox, ide. Yes? All right. Here we have I assume we all know copper is a metal, right? And we have, several other elements, right? Which means that this is, let's go find where copper is, right? So you'd go find copper and be like, oh, look, type 2. So type 2, poly. So we need full name, and charge of the metal. So full name of this part is just copper, right? We know there's going to be a charge here. And full name of this, so your options are only binary or polyatomic ion, yes? Only two options, binary or polyatomic ion. So if I have this CO3, I'm not going to come up with something creative like carbon trioxygen. No, right? CO3 must be a polyatomic ion, right? So we would go look that up if we haven't memorized it already. It is carbonate. Now I just need to work backwards to that charge like we did previously, right? So we will start with what we know from our formula, which says we have 1 copper and we have 1 carbonate. I know that carbonate has a charge magnitude of 2, which means that copper must have a charge magnitude of, correct, also 2, yes? And then that one is done. Finally, we have calcium and that, right? So let's go find calcium. Calcium is right here, right? So it's a type 1. So we will use full name and full name. Yes, does that make sense, right? And so you'll see, right, as a point of contrast, we have this, right, versus this naming over here, yes? As in, I'd belongs to binaries, right? The name of this is 8. So we have to be really conscientious as we're reading the names, right, to pay attention to all the details, right? Just like when you're like conjugating verbs or something, right? You have to be really attentive to what the end of that word says, right? Same thing here. Good? All right. Thank you for listening. Be good. I assure you there is plenty of practice to follow. All right. Be good and I'll see you soon. Bye.